Hello everyone, welcome back to Must Electronics. This is the final result of building Android 14 from scratch. After building, we will get 4 image files, that is boot img, system img, vendor img, plus the final flashable image. These get flashed to a Raspberry Pi SD card and boot into a full Android system. But before we can reach this point, there is one thing we absolutely must get right, that is the build environment. If even one tool is missing or the wrong version, the build fails. And trust me, debugging a build failure after waiting for hours is not fun. In this episode, I'll walk you through setting up everything your machine needs to build Android 14 step by step with the exact versions and commands I use to produce this build you are looking at right now. All commands used in this video are available in the description below. Let's get into it. Quick but important question. Why Linux? In Android's build system, the tools it uses are Make, GCC, Clang, Bash scripts are all Linux native. The Repo tool relies on POSIX system calls and shell features that simply do not exist on Windows. Google does not support Windows build at all. We are using Ubuntu 22.04.5 LTS. If you are on Windows, set up a Ubuntu virtual machine using VirtualBox or VMware. The commands will be identical. Now let's set up the machine. Before touching anything, check that your machine can actually handle this. Three numbers matters. RAM, minimum 16 GB. Less than that and the build will either crash or take all day. Storage, you need 350 GB free. The source sync alone is around 250 GB. After the build, you are looking at 350 GB total. I know, it is a lot. When we come to CPU, more cores, faster build. With 8 cores, expect 1 to 2 hours. Let me verify my system. So this is the Ubuntu version I have. Let me check the space. This is the disk space what I'm using. So the total is 442 GB and the Android repo and build took 345 GB for me and the remaining is 75 GB. If your numbers look reasonable, you are good to go. First things first, update the package list before installing anything. This makes sure we get the latest stable version, not something outdated from the cache. Done. Now the real work begins. Now the big one, build dependencies. This is a single command that installs everything the Android build system needs. I won't go through every single package that would put you to sleep, but let me call out the ones that actually matters. The build essential installs GCC, G++, and Make, which are the actual compilers. Without these, nothing gets compiled. Here is something that surprises most people. GCC Multilib and G++ Multilib allows a 64-bit machine to compile 32-bit code. Android 14 is 64-bit, but it still contains some 32-bit vendor libraries. If you skip these, the build will fail deep into the process, not at the start. This is a frustrating way to find out. Other packages like libxml2, flex, bison, curl are the supporting tools the build system calls under the hood. You will never directly interact with them. Let me copy this command and run. I have already installed all the packages. Now because we are building for Raspberry Pi using Raspberry Vanilla project, there is a second set of packages that this project specifically requires. The interesting ones here are Ninja build. Ninja is a fast build engine that soon drives under the hood. Kpart X and DOSFL tools are used when the build assembles the final SD card image. Without these, the image creation step fails at the very end. Let me copy this command and run. Finally, the Python packages Raspberry Vanilla need to be installed. These are Python build utilities, template engines, and parsers used by some native components. They are specific to the Raspberry Vanilla build. Standard AOSP does not need them. As I have already installed all these packages, it says the requirement already satisfied. Let me clear the screen. Now let's do a quick sanity check. Yeah, GCC is already installed. Yeah, Python is also available. Even the make is also available. This is the step where most people waste time, that is for Java. If you search online, you will find people saying Android 14 needs OpenJDK 21. Some are right, some are wrong. It depends on the project. For the Raspberry Vanilla build we are doing in this series, the correct version is OpenJDK 11. I know this because I have already built Android 14 with it. If you are using wrong Java version, the build will fail with cryptic errors and you will spend hours wondering why. Now let's install OpenJDK 11. May I have already installed. I'll check the version. Yeah, it's available. Currently for me, only one Java version is showing. If you have multiple Java versions on your system and it shows a different version, fix it with this command. As I have only one version, there is nothing to configure. Why does the build need Java at all? Because the Android framework and apps are written in Java and Kotlin, and the build tools that convert that code into Android bytecode are themselves Java programs. Java is not just a language here, it is part of the build infrastructure. Android source code is not one Git repository, it is over 800. The repo tool is how Google manages all of them together. One manifest file describes every repository, its branch, and where it goes. One command, repo sync, fetches all of them in parallel. Installing it on Ubuntu is simple. Let me verify it. You will see repo not installed at the top. Do not panic. That just means the full repo client has not been downloaded yet. That happens automatically in the next episode when we run repo in it. The launcher is working. That is all we need right now. One last thing before verification. Configure Git. Repo uses Git internally across all repositories it manages. If Git has no identity configured, repo fails early with an unhelpful error. Set it now and never think about it again. This is stored only on your local machine. It does not need to match any account. Now, the most important step, verify everything before moving on. Do not skip this. A single missing or wrong version tool will fail the build hours later when it is much harder to diagnose. Here is exactly what you should see on a correct setup. The one to pay most attention to is Java. If it shows anything other than 11, go back and fix it before continuing. Also verify your Git identity is set. If everything matches, your machine is ready. Let me show you what you are building towards. This is what all of that setup produces. Boot IMG, the kernel and RAM disk, system IMG, the entire Android framework and all system apps, vendor IMG, hardware specific libraries and HAL implementations, and the star of the show, Raspberry Vanilla image. This is the complete ready to flash SD card image. You write the single file to an SD card, plug it into Raspberry Pi, and Android boots. Every tool we just installed played a role in generating these files. That is why none of the setup steps were optional. Now your machine is ready. That is the entire build environment. In the next episode, we initialize the repo with the Android 14 manifest, add the Raspberry Pi local manifest from Raspberry Vanilla, and run repo sync to pull down the full source code. One warning, the sync is around 250 GB. Make sure your internet and disk are ready before starting that episode. If this video was helpful, please like the video and subscribe to Must Electronics.